Hello and welcome. I am excited to guide you through designing robust Azure infrastructure for your AI applications and agent-based solutions using Microsoft Foundry. Let us architect the future together. Welcome to this critical module on designing Azure infrastructure for AI applications and agent-based solutions. When building enterprise-grade generative AI applications, the foundational architecture dictates your project's scalability, security, and long-term success. Azure provides numerous standalone AI services, but provisioning and managing these individual resources manually can quickly become overwhelmingly complex. This is exactly where Microsoft Foundry enters the picture. Microsoft Foundry serves as your comprehensive, unified platform for end-to-end AI development on Microsoft Azure. Instead of stitching together disconnected cognitive services, data stores, and compute clusters, Foundry provides a structured, project-based environment. This structure vastly simplifies resource management, access control, and model deployment across your entire organization. By leveraging Foundry, you gain a centralized hub to orchestrate everything from your large language models to your custom tools and evaluation metrics. In this module, we will deeply explore the core infrastructural decisions you must make when setting up a Foundry environment. We will thoroughly cover how to seamlessly integrate pre-built Foundry tools, configure your developer environments with the appropriate SDKs, design robust architectures for autonomous AI agents, orchestrate complex multi-agent workflows, and finally, implement essential responsible AI guardrails to ensure your solutions operate safely in production. Designing the right infrastructure upfront prevents costly refactoring later and empowers your development teams to focus strictly on building innovative AI capabilities rather than managing complex backend plumbing. Your infrastructure choices form the bedrock of your application's reliability. Let us dive into the details and look at how Microsoft Foundry logically organizes these critical components. This code establishes a connection to the Microsoft Foundry project using the AI project client. This single connection string links your application to all managed infrastructure and deployed models. This flowchart illustrates how Microsoft Foundry acts as the central hub for your Azure AI infrastructure, seamlessly branching out to Foundry tools, agent services, safety evaluations, and developer SDKs. A core principle of designing effective AI infrastructure on Azure is recognizing that you absolutely do not always need a massive, expensive generative AI model to solve every single problem. This brings us to the strategic integration of Foundry tools into your architecture. Microsoft Foundry encompasses a suite of pre-built, out-of-the-box APIs known as Foundry tools. These tools provide specialized, highly optimized capabilities for common artificial intelligence tasks. For example, if your enterprise application needs to extract key-value pairs, tables, and structured data from thousands of PDF invoices, you should architect your solution to use Azure Document Intelligence rather than prompting an LLM to parse the raw text. If you need to translate audio in real time or transcribe meetings, Azure Speech and Foundry Tools is unequivocally the most efficient choice. By strategically routing specific, well-defined workloads to these dedicated Foundry tools, such as Azure Language for Entity Extraction or Personally Identifiable Information Redaction, you create a significantly more cost-effective and highly predictable solution. This architectural pattern allows you to reserve your expensive generative AI model tokens strictly for tasks that genuinely require dynamic reasoning, context understanding, and complex text generation. When designing your Azure infrastructure, you must meticulously map your business requirements to these available tools and provision the necessary Azure resources within your Foundry project. This hybrid architecture, smoothly combining the deterministic reliability of Foundry tools with the dynamic reasoning capabilities of generative models, represents the absolute gold standard for enterprise AI design, ensuring optimal performance while strictly controlling your operational cloud costs. This snippet illustrates the use of a pre-built Foundry tool, specifically Document Intelligence, to efficiently process an invoice parsing task, effectively offloading work from the primary generative AI model. This visual demonstrates a hybrid routing architecture. The application routes translation, extraction, and parsing tasks to dedicated Foundry tools, reserving the generative LLM exclusively for complex reasoning tasks. Once your core Microsoft Foundry resources and pre-built tools are securely provisioned, you must establish an optimal working environment for your software development team. Designing your developer infrastructure revolves heavily around choosing the correct software development kits, or SDKs, and the right integrated development environment. In the sophisticated Azure AI ecosystem, you will typically utilize two primary SDKs to build your applications. The standard OpenAI SDK provides full compatibility for direct model inferencing, allowing you to seamlessly generate dynamic responses using chat completions APIs. However, to interact with the broader Foundry infrastructure, such as managing agent lifecycles, configuring complex tool connections, executing automated evaluations, and tracking telemetry, you must integrate the powerful Microsoft Foundry SDK. For the development environment itself, Microsoft provides the highly capable Microsoft Foundry extension specifically for Visual Studio Code. This specialized extension essentially transforms VS Code into a comprehensive, enterprise-grade AI development platform. Instead of constantly context switching between your local code editor and the Azure Portal web interface, your developers can build, test, and deploy AI agents directly from their preferred IDE. The extension allows you to seamlessly configure agent instructions, attach custom functions, and instantly test agent behavior using locally integrated chat playgrounds. By strategically standardizing your team's developer infrastructure on Visual Studio Code with the Foundry extension and utilizing the Foundry SDK for overarching project management, you absolutely ensure a highly streamlined, efficient, and consistent development lifecycle, from initial prototyping all the way through to production deployment. This approach dramatically reduces developer friction and accelerates your time to market. While the Foundry SDK expertly manages project assets and AI agents, developers seamlessly use the Azure OpenAI SDK to handle direct model inferencing against the securely deployed Foundry endpoints. This diagram showcases the developer toolchain. Developers use Visual Studio Code with the Foundry extension for configuration and testing, utilizing both the Foundry SDK and OpenAI SDK to communicate with Azure endpoints. Let us now shift our focus to designing infrastructure specifically for modern agent-based solutions. Traditional generative AI applications often operate as simple, stateless text generators. AI agents, however, are sophisticated, dynamic systems explicitly designed to understand complex context, make independent decisions, and execute autonomous actions to achieve specific business goals. To properly support this advanced functionality, you must leverage the Microsoft Foundry Agent Service. The infrastructure of an effective AI agent consists of three critical foundational pillars: the core reasoning model, persistent conversational memory, and tightly integrated tools. Instead of building custom, error-prone database schemas to manually track ongoing conversation history, you should architect your solution to use Foundry's native thread management. Threads securely store the ongoing session state and automatically optimize token usage when continuously interacting with the language model. Furthermore, you must aggressively design the infrastructure to support dynamic tool execution. This involves directly configuring built-in capabilities like the code interpreter tool for rigorous data analysis, the web search tool for real-time internet information retrieval, or integrating custom function calling that securely connects to your proprietary internal enterprise databases. When you build an agent using the Microsoft Agent Framework, you are essentially creating a highly capable, autonomous orchestrator. Designing this precise agentic infrastructure correctly is absolutely critical for building automated, resilient systems that can securely interact with your internal business operations and deliver true enterprise value. The framework natively abstracts away the underlying compute, allowing you to focus entirely on defining the agent's behavior and the tools it is authorized to invoke. This crucial code utilizes the Foundry Agent Service to instantiate an AI agent, specifically equipping it with secure external tools and establishing a thread to natively handle persistent conversational memory. This structural layout reveals the three pillars of the agent service: the generative LLM for reasoning, persistent threads for stateful memory, and a dynamic suite of built-in and custom integrated tools. As your enterprise AI requirements inevitably become more complex, utilizing a single, isolated agent will often be insufficient to meet your business needs. You must therefore design your Azure infrastructure to be fully capable of orchestrating sophisticated multi-agent solutions. In Microsoft Foundry, you achieve this advanced orchestration by using workflows. Workflows provide a highly structured, declarative visual approach to orchestrating AI-driven actions. Instead of writing massive, fragile blocks of complex Python code to manually route tasks between different models, you utilize the Visual Workflow Builder to seamlessly connect distinct functional nodes. Each individual node within your workflow can represent a highly specialized AI agent, a rigid logic evaluation, or a specific data transformation step. For example, you might design a comprehensive workflow where a user's initial request is first evaluated by a routing node. If the request is technical, it is automatically routed to a specialized coding agent. If it is an account inquiry, it is sent to a dedicated billing agent. You can expertly implement sequential orchestration, where agents pass refined outputs in a linear chain, or concurrent orchestration, where multiple agents process subtasks simultaneously to drastically reduce overall latency. Furthermore, for highly advanced enterprise scenarios, you can utilize the agent-to-agent, or A2A, protocol to cleanly allow remote agents hosted on completely different servers to communicate securely. By intelligently designing your infrastructure around these structured workflows, you ensure your AI systems remain highly modular, incredibly easy to securely monitor, and far simpler to debug. In a programmatic workflow architecture, the explicit output of one highly specialized agent, like a writer, is seamlessly routed as the input to a secondary specialized agent, an editor, to finalize complex operations. This node-based execution map illustrates multi-agent orchestration. A central workflow router divides subtasks among parallel generation agents, which then cleanly filter their results into a final reviewer agent. Finally, no Azure AI infrastructure design is completely viable without a rigorous, deeply integrated implementation of responsible AI principles. Generative AI models are undeniably incredibly powerful, but they naturally carry inherent risks of generating harmful, biased, or highly inappropriate content. To comprehensively protect your enterprise reputation and your end users, you must actively design your infrastructure with strict, systematic safety guardrails. Microsoft strongly advocates a comprehensive four-step process for this: map, measure, mitigate, and manage. First, carefully map out the specific potential harms relevant to your exact use case. Next, systematically measure the actual presence of these exact harms by running automated evaluation metrics against diverse datasets within the Microsoft Foundry portal. The most crucial infrastructural step, however, is mitigation. In Microsoft Foundry, you reliably implement mitigation directly at the safety system level by fully configuring content safety guardrails. These robust guardrails sit seamlessly between the end user and the language model, automatically intercepting and aggressively blocking user prompts that clearly violate security policies, as well as actively filtering out generative model responses that contain toxic or restricted content. You do not have to build these complex safety filters from scratch. They are natively integrated. Designing your architecture with these responsible AI guardrails from day one is simply non-negotiable. Thank you for joining this session. If you found this useful, please invite your colleagues to like and subscribe. Visit quicktechie.com for premium certification prep, including Q&A banks, ebooks, audiobooks, expert training, and interview guides. See you next time. This code demonstrates the crucial measurement phase of responsible AI, executing automated evaluations against a test dataset to forcefully verify that your systemic safety guardrails perform effectively. This critical safety workflow visualizes how infrastructure-level guardrails actively intercept unsafe prompts before inference and meticulously filter out any toxic model responses before delivery to the end user.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.